In this video, I'll discuss a simple procedure on how to find the inverse of invertible functions. Here, we'll let f be a function with domain A and range B. Then its inverse function is the function f inverse, whose domain is B and range is A. You can look at the inverse function as a function that returns the original value for which the function has given the output. We use this notation f inverse to denote the inverse of the function f. A function that has an inverse is said to be invertible. Note that not all functions have an inverse, so we say that not all functions are invertible. Now, we'll formally define the inverse of a function. We say that a function f inverse is the inverse of f if, for every x in the domain of f inverse of f of x is equal to x, and for every x in the domain of f inverse, f of f inverse of x must also be equal to x. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. Okay? Given the function f of x, we can find the inverse function f inverse of x by following these steps. First, replace f of x with y. Well, this is customary in defining functions because we usually define y as a function of x. Okay? Then replace, as the second step, replace every x with y and replace y with x. And the third step would be solve the equation from step 2 for y and replace y with f inverse of x. The resulting equation is then the inverse function. Now, the fourth step is actually an optional one. This serves as a way to determine whether that expression for the inverse is actually correct. Okay? So that is, we verify our work and make sure that these two conditions are being met. That is, these two compositions hold. F inverse of f of x must be equal to x in the same manner as f of f inverse of x must also be equal to x. Okay, so let's take a look at this first example. We'll find the inverse of this function f of x defined as 2x minus 5, right? So then we'll undergo the four-step procedure. First step is we let y be equal to f of x. So this will now be y equals 2x minus 5. Okay? Then the second step would be we'll replace these variables. Y will be replaced now with x, as x will now be replaced with y, to have x is equal to 2y minus 5. Then we are ready to solve for the variable y in the third step. Okay, that is, we'll isolate y on one side of the equation in terms of then y will of course be in terms of x. Okay, doing so, we'll now transpose this negative 5 to the other side, and it will of course become positive 5. Hence 2y will then be equal to x plus 5. And dividing both sides of the equation by 2 to isolate the variable y, will now have what? Of course, this will now be equal to 1. Hence, y will be equal to x plus 5 all over 2. Then, actually, this will now be f inverse of x, which is equal to x plus 5 all over 2. Okay. Step number 4 will then serve as a checking. That is, we need to verify these two composition of functions. We need to show that f inverse of f of x should be equal to x. And later on, we'll be showing also that f of f inverse of x is also equal to that variable x. Now we'll derive this equation. Okay, so f inverse again is given by this expression. Okay, so first we'll have what? F inverse of f of x, right? By definition of composition of functions. Now f inverse is given by this expression, so this will now be what? Equal to x plus 5 all over 2. Okay, however, again, we'll have this as x star for it to differentiate it from that variable x. And take note, this is now the independent variable defining f inverse in this expression, and f of x is equal to 2x minus 5. So that means to say, we'll now substitute this 2x minus 5, okay, into this variable x star to come up with what? 2x minus 5 plus 5 all over 2. Simplifying further, negative 5 plus 5 is equal to 0, and we'll now have what? This will now become 2x all over 2. Of course, this will be divided to 1, hence this is equal to the variable x, which is what we want to show. So meaning this is now true. Okay, for the second condition, we also need to show that f of f inverse of x is equal to the variable x. Okay, this of course will be equal to what? F of, by definition of composition of functions, f of f inverse of x, right? And then again, the function f is of course given by this expression 2x minus 5. So this will be something like 2x minus 5. But of course, to differentiate this x from that original variable x, then we'll have it as x star. Okay, and take note, this is f inverse of x, whose expression is equal to this one here. So we'll replace this x star, okay, with this x plus 5 all over 2. So this will now become, okay, 2 times x plus 5 all over 2. Okay, and we have minus 5 here, so it will remain. So this will be minus 5, right? Simplifying further, we can now divide this 2 here into 1 and have the equation and have it to be equal to x plus 5 minus 5, which of course negative 5 minus 5 is 0. So thereby, this is now equal to x. So meaning to say, this is true, no? This equation. So we have just proven then that indeed, okay, this f inverse of x would take this value or expression, okay, x plus 5 all over 2. Let's have another example. Suppose g of x is equal to square root of x minus 7. Okay, there. So we'll find for g inverse, okay, or the inverse function of g of x. Okay, so undergoing the 4 steps there. So step 1 is we'll let y be equal to that function g of x, and that will be equal to square root of x minus 7. Okay, then second step is replace y with x and replace the variable x with y, and we'll come up with that equation: x is equal to the square root of y minus 7. Now in the third step, we need to isolate y, okay, on one side of the equation. That is, we'll solve for y. Now take note, okay, again the equation is square root of x is equal to the square root of y minus 7. Here we are dealing with a radical, that is the square root of y minus 7. To eliminate that radical, we need to, the radical sign. To eliminate the radical sign, we need to take the square of both sides, okay, the equation, right? Note that the square root here has an index 2 there, okay. Of course, we can now cancel this out, the square there and the radical sign, right? To come up with x squared is equal to y minus 7. Hence, we are now ready to solve for y by transposing this negative 7 to the other side to have y equals x squared plus 7. This is now g inverse of x, okay? This is now equal to x squared plus 7, okay? Now, to verify the two conditions in the fourth step, to make sure that indeed, okay, this is the correct expression for g inverse, okay, we'll then again show that what? G inverse of g of x must be equal to x, and g of g inverse of x must also be equal to the variable x. Okay, first we'll have g inverse of g of x, and we'll show that this is equal to that variable x. Okay, now by definition of composition of functions, again, this will be what? Equal to, take note again, no, this is the main function there, so this will now be equal to g inverse of the second function g, okay, g of x, right? Now g inverse should take this form, x squared plus 7, so we can write it out as x star squared plus 7, where x star will be what? This g of x, and g of x is given by this expression, square root of x minus 7. So meaning to say, we'll now substitute this square root of x minus 7 into this variable x star in our next step. Okay, so this will now be equal to, okay, the square root of x minus 7 quantity squared plus 7, okay, and of course this will be equal to x minus 7 plus 7, which is of course equal to the variable x. Okay, now we'll show the second condition, g of g inverse of x must be equal to x. Okay, so we'll show this again by definition of composition of functions. This will now become what? Taking into consideration this as the first function there, and it will now become the main function, so it will now become g of what? G inverse of x, right? So this will be g inverse of x, serving now as the independent variable. Okay, take note that the function g, okay, this function there has this form, okay, square root of x minus 7. So this will now become what? Square root of the variable x, but let's make it as x star minus 7. Okay, now this is g inverse of x given by this expression here. So this tells us that we need to substitute this variable x star, okay, with x squared plus 7. So the next step now will then be what? Okay, the square root of x squared plus 7, okay, minus 7, right? And simplifying further, of course, this will be 7 minus 7 is 0, and this will now be the square root of x squared, which will in turn be equal to the variable x, okay? This variable x. So we just have successfully shown that this composition of functions is equal to this variable x. Thereby, we're saying that this is then the correct expression for this g inverse, right? Now, let's take another example. Suppose we have this function h of x, okay? It says equal to 2x plus 5 all over x minus 4, okay? So we have here a rational expression for this function h of x. Then we'll find for the inverse, right? So again, undergoing the four-step procedure, first we'll let y be equal to that function h of x, okay? So this will now become 2x plus 5 all over x minus 4, okay? Now in the second step, we'll now replace y with x, okay? And replace x with y, right? Then this will now become y is equal to, x is equal to 2y plus 5 all over y minus 4, right? Now in the third step, we need to solve for y, okay? So do it. We'll now multiply both sides by y minus 4, right? And we'll come up with x times y minus 4, which is equal to 2y plus 5, okay? And simplifying further, this will now become xy minus 4x is equal to 2y plus 5. Take note, our goal is to isolate y on one side of the equation. So transposing this 2y, okay, to the other side, it will of course become minus 2y, right? So this will now become what? Xy minus 2y, okay? And transposing negative 4x to the other side, we'll have 5 plus 4x, right? Now, we can now, since y is a common factor between these two terms here, we can now extract y and have what? X minus 2, okay? It says equal to, we can rearrange the terms here, 4x plus 5, right? Okay? And to continue, dividing both sides by x minus 2, we are now ready to have the value of y, which is equal to 4x plus 5 all over x minus 2, right? Okay, and this is now the inverse function, the expression for the inverse function. H inverse of x is 4x plus 5 all over x minus 2. Okay? Clear? So, right? I hope you learned something from this video. Thanks for watching.